Hi everyone, and welcome to today's session, Agentic AI, a practical introduction. My name is Fraser Deer, and I head up the AI and data innovation team here at BCN. I'm going to hand over to my colleague, Ban.
Thank you, Fraser, and hi everyone. My name is Ban Hassan. I'm an AI and data innovation consultant here at BCN. Today is a practical introduction to Agentic AI, what it is, how it differs from regular chat AI, and where it's actually useful at work. The key shift is this. We move from AI that responds to prompts to AI that can actually pursue a goal through multiple steps. We'll keep this grounded in examples such as knowledge Q&A, an intelligent help desk, and continuous operations. We'll start with a clear definition of what an agent actually is. Then we'll look at the building blocks, the minimum architecture needed for an agent to work safely. Then, 3 patterns that you'll recognize from real business use cases. And finally, what agents are good at, where they fail, and the practical so what. I'll hand over to Fraser to define what an agent is.
So what is an agent? An agent is an AI system that's designed to achieve an objective by taking actions across steps, not just generating text. It operates inside a loop. Understand the goal, plan, take actions, check progress, and adjust. And there are 2 important parts in that definition. A, it's goal-driven, and B, it can take actions, often through tools or other systems. Regular AI is typically you ask and it answers. Agentic AI is you set a goal, it figures out and executes the steps. The difference isn't smarter, it's autonomy and workflow execution. And autonomy exists on a spectrum from fully human-led to largely automated. A language model is like a knowledgeable person you can ask questions to. An agent is like giving someone a task. They break it down, they can check progress, coordinate resources, and iterate until it's done. That's why agents are so powerful. They reduce the effort of managing a multi-step workflow, not just writing content. To work reliably, an agent needs a few core components. Otherwise, it's just guesswork with extra steps. Think of this as a minimal viable system. Behind an agent, planning, tools, validation, and then context. These 4 components create the iterative cycle that makes agents work. Planning, the work breakdown structure. Converting a goal into steps and sequencing them. Tools, how the agent touches reality through APIs, databases, ticketing systems, calendars, CRMs, and so on and so forth. Validation, quality gates. Did the action succeed? Does the result match the success criteria? Should we retry or should we escalate? And then context, memory of what's already happened so the agent doesn't repeat itself and can build upon the progress that it's already made. Together, these 4 elements create an iterative cycle. Plan, act, check, refine. Planning is the first core component. This is where the agent converts a high-level goal into a sequence of actionable steps. Good planning means that the agent can break down complex objectives into manageable tasks. Sequence steps in the right order. Identify dependencies between each of the steps, and then replan when something goes wrong. And the quality of the plan directly determines the quality of the outcome. Poorly planned agents waste compute and produce unreliable results.
And the second is tool integration. Tools are how the agent interacts with the real world. Without tools, an agent is just a model that can think but cannot do. In practice, tool integration means connecting to APIs, databases, file systems, and ticketing platforms, reading and writing data in structured formats, calling functions with the right parameters like MCP servers, and handling errors and retries when tools fail. The quality and reliability of tools is a major factor here. If the tools are flaky, the agent fails, because its hands don't actually work. And third is validation and feedback loops. Validation is what separates a useful agent from a dangerous one. After every action, the agent needs to check, did this work? Does the result match what I expected? Should I retry, adjust, or escalate? So let's break this down. Success criteria is the agent needs a clear definition of done. Error handling is what to do when something fails. Escalation rules is when to hand off to a human. Without feedback loops, agents can repeat the same mistake indefinitely, or silently produce wrong results. This is where governance plugs in. And finally, contextual learning. Context is the agent's working memory, what has happened so far, what has been tried, what succeeded, and what failed. Without context, the agent loses track. It might repeat actions, contradict itself, or misinformation it has already gathered. Good context management means the agent gets better within a task, building on each step rather than starting fresh every single time. I'm now going to hand over to Fraser for the Microsoft agent ecosystem.
This slide maps the Microsoft ecosystem to the spectrum of agent complexity. On the left, we've got lower complexity, things like Copilot and Copilot Studio for guided, pre-built agent experiences. In the middle, we've got Copilot Studio and Power Platform, because these are for more customized, workflow-driven agents. We might start to integrate fine-tuned models at this stage, perhaps an MCP server. And on the right-hand side, we've got the highest complexities, things like AI Foundry and Agent Framework, for fully customized, code-first agent systems. The point here isn't to pick the most advanced option, it's to match the tool to the use case complexity. So we need to start simple, on the left-hand side, and move to the right only when you need to. So I'm going to hand back over to Ban to look at some real-world examples.
Thank you, Fraser. Now let's ground this in 3 patterns you'll see in organizations. Each pattern increases autonomy and reduces the amount of human driving required. The first example is knowledge Q&A. This is the simplest agentic pattern, retrieval augmented generation, also known as RAG. Humans initiate every query, and the system just retrieves relevant documentations and drafts an answer. The key point here is that there is no autonomy. The human still drives every interaction. Where it shines is policy Q&A, procedures, onboarding, or internal knowledge bases. Where it fails is if the documents are missing, outdated, or conflicting, it could still produce confident nonsense unless you force citations and validation. The second example is intelligent help desk. Here you still see one interface, but behind it there are specialist agents. A triage agent that classifies the issue and routes it, a research agent that searches knowledge bases and past tickets, a response agent that drafts the fix with steps, references, and an action plan. Why this matters is because it reduces time to resolution and standardizes quality. Human involvement is still meaningful, but now the human is reviewing and approving and not doing the whole workflow manually. And lastly, continuous operations. This is a more autonomous pattern. The agent runs continuously. It monitors signals, detects issues, plans a response, executes actions, and then reports outcomes. Here, humans are typically on the loop. They get escalations or periodic reports rather than initiating every single task. This is powerful, but it also is where governance matters most. What the agent is allowed to change, what it needs approvals, and what must be logged. I'll hand over back to Fraser for key capabilities.
So what are the key capabilities? What makes an agentic AI different in practice? So we're going to look at those 4 capabilities that show up repeatedly. So what are those 4 key components? Multi-step reasoning. Agents can carry a task through multiple steps rather than just stopping at the first answer. We've also got adaptive planning because they don't follow rigid scripts. They adjust based on the outcome of the previous step, an error, or new information that's been introduced in the workflow. Transparency is a really key aspect here because actually a good agentic system makes reasoning and actions inspectable. So we need to think about logs, the steps that have been taken, the sources that have been used, and the rationale behind the decisions that have been made. And then of course we've got tools and orchestrations and MCP servers, as I referred to earlier on. This is the operational core, and selecting the sequencing and tools correctly and using the guardrails so that tools can be safe and auditable. The punchline here is agents don't just think, they do and use tools to do so. Now, many people ask us, what are the limitations behind agents and agentic AI? They're not magic, they fail in predictable ways. And knowing those limitations in how we deploy, develop, and safely avoid expensive, embarrassing outcomes is really, really important. AI is more than just intelligence. A good system requires two human aspects. One is trust. Does the end user trust what's going on in the system? Two, intelligence. The human needs to assess whether or not the output from whatever the system is actually is adding value. And those two aspects are the human aspects required for a solution to be valid. The second two aspects are data and process. If you've got good quality data that you can rely on, and you've got a process that's to be followed, that's when AI can come into its own. Data and process to feed the AI, human intelligence to establish whether or not the AI is doing what it needs to do, and actually forming a really high quality outcome, and trust. Does the human recognize and value that output? Most failures happen because one of these pillars is missing, not because the model isn't intelligent enough. As we've just established, agentic AI isn't a silver bullet. You need well-defined state spaces. So agents work best when the workflow has clear states: intake, check, approve, execute, close. You need reliable feedback. Agents need strong signals to know what success should look like. Otherwise, they loop or guess. You need a computational cost because actually, agents can be more expensive because they can do multiple steps, retries and validations. So you need to think about that as you go through your build phase. And then tool quality. If the tools are flaky or permissions are messy, agents will fail because their hands don't actually work. They can't assume. And so if you don't have the right permissions in place, the agent could do something unexpected. So start with bounded workflows, strong success criteria, and high quality integrations with systems that you trust. Let's hand back over to Ban to look at the bottom line.
Agentic AI is best understood as moving from prediction to execution. It's not just a chatbot that writes better, it's a system that can run workflows. The winning approach is incremental, starting with RAG, move to multi-agent help desk patterns, and then adopt continuous operations where it's safe and valuable. Today's key takeaways are: make them goal-driven. Agents aim to achieve outcomes, not just produce text. Make them iterative. They plan, act, validate, and adjust, which is why guardrails matter. And make them operational. They can execute work, but only safely when the workflow, tools, and oversight are designed properly. If you remember one thing, treat agents like junior operators. Give them bounded authority, clear success criteria, and strong auditing.
Okay, we've come to the end of today's content. Do we have any questions? Well, there are a couple of questions I thought we might walk through. So Ban, where in business workflows could an agent replace a manual multi-step process?
That's a good question. I think strong candidates are high volume, repeatable, and have clear steps. So for example, if you have ticket triage and response drafting, where the process would be classify issue, pull relevant knowledge base and or past tickets, and then draft steps and escalate when uncertain, then that would be a good workflow. Or if you have onboarding or access requests, where you would collect required fields, validate eligibility, open tickets, and track completion, and also notify the users, that would also be a good candidate. So the rule of thumb here, I think, is if a workflow is already a checklist people follow repeatedly, then it's usually agent ready. So Fraser, we hear this question a lot from our clients. How much autonomy are we comfortable giving an AI solution before a human must intervene?
Ban, that's a great question. Autonomy and agents are one of the key risk factors when it comes to adoption. So I'm going to suggest a 5-step ladder. Step 1 is suggest only, where agents draft the steps and humans perform the actions. Step 2 would be allow the agent to execute some of the low-risk actions. So perhaps the agent can run read-only queries or create drafts, maybe open some tickets, but then only allow them to schedule some of the easy and low-risk activities. Step 3 would be execute with approval gates. So the agent might prepare actions and the human approves the commit step. Maybe the sending of the email, the changing permissions, the deployment configuration. Step 4 is autonomous within boundary conditions. So the agent would run an end-to-end process, but only for pre-approved workflows, with monitoring, rollback, and full audit logs. And then finally, step 5, continuous operations. This is where we've got a fully autonomous agent running all of the activities within the scope of the agent, but we've got autonomous monitoring and remediation with escalation thresholds and mandatory reporting. So where would I start? I would start perhaps at level 2 and maybe level 3, where we've got low-risk execution and approval gates, and then only expand when you've got clear success criteria, really strong logging, and stable tool integrations. And one of the key aspects here is don't move up the ladder until everybody is happy, because of course, as soon as you up the autonomy, you may run into challenges. So that's it for today, folks. Thank you for your time, and if anything that we've covered today sparks further questions, or you'd like to explore further any of the topics in more depth, please reach out to us here at BCN. We'd be more than happy to help, whether it's a technical deep dive, guidance on specific use case, or support with your whole AI adoption journey. Thanks for your time today.